Lesson 7.4 is on solving one-step inequalities. Let's do a quick review of the inequality symbols. The first is less than. And so this would always point to the smaller number like this. We could say 5 is less than 6. So that's one way that could work. Or less than or equal to, when we put this lower horizontal line in, it's an or equal to. So we could actually on this one say 5 is less than or equal to 5, and it's still true. A third symbol is the greater than symbol, and we just kind of switch things around here and say 6 is greater than 5. And then a fourth one is the greater than or equal to symbol, and again we could say something like, we could say 5 is greater than or equal to 5, and it's all true. If we have a statement that says something like x, a certain number x, is greater than 7, there's an infinite number of solutions that make this true. It could be 8, 8 and 1/10, 9. I mean, I can't list them all, but I can show them all if I put them on a number line. And when I put my number line in, I have to name 2 points, and it's convenient. I have to name the 7, so I'll just put 7 here. And then 0 is another good one to put in. And then if it's greater than 7, I have to indicate on the number line that it cannot be 7. And I'll do one of two things. I'll either put a dot or a circle. Dot includes that number, so it can't be 7. It's not true that 7 is greater than 7, so I cannot use the dot. So I'm going to use a circle, which means does not include 7. Then to indicate that it's everything that's larger than 7, I put like bold-face that line going to everything greater than 7 and put a little arrowhead on it. So it's really array. It's an array that goes from 7 but doesn't include 7. But again, the circle means it doesn't include that point, and the dot means it does. It's something that seems to cause an undue amount of uncertainty, but it's pretty simple. Dot, it can include it, and circle, it doesn't include it. So if I wanted to say it can be 7, like if I put in the or equal to symbol, greater than or equal to 7, then I could fill this in with the dot, which means it can be 7. It's sort of a rather large dot there, sort of overdone, but that's what I had to work with. So this would be the solution to x is greater than or equal to 7. One-step inequalities are solved in a similar manner to one-step equations. You'll have either an addition or subtraction or a multiplication or division to undo. In this case, if I double the variable, I get something greater than or equal to -4. So if I want to know how that relates to just the x, just the variable, I have to undo multiplying by 2. So I just put divide by 2, and divide by 2. This will be 1. So x is left that x is greater than or equal to. And then you have to remember your rules for working with integers, and you might have fractions involved here or decimal numbers. But -4 divided by +2 is a -2. Then I interpret the statement that x is greater than or equal to -2. Draw the number line. I'll put a 0 and a -2 on the number line. When I see the or equal to symbol, I know it can include the -2, so I'm going to put the dot at -2. And it can be greater than, so I know that goes to the right. So I highlight it and put the arrowhead on it. So that's the solution to x is greater than or equal to -2. Now let's look at a few other examples. In this example, I have to undo adding -4, and there are two ways to go about it. I can either add a +4 or I can subtract -4. And if you think about subtracting -4, that's going to change to add +4. So I might as well just start right away by doing add 4. So this would be a 0 pair, leaving me with just the x. And then let me erase that. So I'm going to put in add 4 over here, so +4. So when I do 6 negatives and 4 positives, the net is 2 negatives. So x is less than -2. So I'll put a -2 in here and a 0, and go less than, so I circle it and go this direction. So that's everything less than -2. Let's take a look at a more complicated example. I'm saving, kind of going from the easy ones to the more difficult ones as we progress through. There'll be something unique and special that happens when you multiply or divide both sides of an inequality by a negative number. Let's start with something that you know is true, that -7 is less than -2. So it's true, it's further to the left than -2. if you're down by 7 points in a basketball game, you're further down than if you're down by 2. So if I multiply both sides by -2, see what happens, what kind of statement results. -2 times -7 is +14, and -2 times -2 is 4, and it is not true that 14 is greater than 4. And what you have to do when you're multiplying by a negative number is switch the inequality. So let me show you what I should do. I have to erase a few things here. Just bear with me for a second while I erase the false information and go to what I really want to do. First of all, I wouldn't write these on the same line. If I'm going to multiply or divide by a negative number, I'm going to have to show the multiplication, -2 times -7. Then I have to switch the inequality. So I'm going to take this symbol and I have to switch this to be greater than. Put that parentheses in there. This means I have to write the second line. I mean, it's just no way to get around it if I want to write things that are true. I can't just copy it down and then write times multiply by 2 here, multiply by -2 here, and multiply by -2 here. I have to recopy the whole thing, making sure that I switch this inequality symbol. And as I do that, then I'll get a true statement. I'm going to get a statement that says 14 is greater than 4. So let's see how this works with a variable. Okay, suppose I was given the inequality that a number divided by -3 is greater than or equal to 4. So now to undo this dividing by -3, I'm going to have to multiply by -3. So I've got to recopy it. And when I get to the inequality symbol, I just switch it to be less than or equal to 4. Then I can put times -3 actually. And then 4 times -3. And the result's going to be a true statement. So this will be n is less than or equal to -12. And when I graph it, I can put in a 0 and a -12. It can be less or equal to -12. So it's going to include -12. And it goes to the left. Hit on there. So that's how you handle that multiplying or dividing by negative numbers. And then the last thing I want to take a look at with you is the compound inequalities. There are two types of compound inequalities. You'll have things that will be connected with the word and then you'll have some that are connected with the word or. And when you get this kind of statement, you just have a line segment as your solution. And when you get this, it'll be 2 rays. That'll be the solution. So let's take a look at the and statements. So if we have something like 16 is greater than or equal to -4x and 4x is less than or equal to 12. We just solve them separately. So we're going to have to, on the one on the left, we're going to have to rewrite it actually because we're going to have to be dividing by -4. And so the resulting statement is that -4 is less than, actually this is more of a complicated kind of a inequality too because the variable's on the left-hand side, which presents another kind of complex issue. But we know that -4 is less than x. Now if you read this backwards, this is how you handle this kind of statement where you have the number first, then an inequality, and then the variable. You can just read from here, x is greater than -4. So, and then that's the same thing as saying -4 is less than x. So let's solve the other part of the inequality, which is that when we divide by 4, we don't have to switch the inequality here. So in this one, x is less than 3. So what we're actually going to end up with here is something between 3 and -4. So when we graph it, it's very convenient to put these 2 points on, -4 and +3. And then just graph what each one says. The x is less than 3, can't include 3, so we put a circle, and we go this direction. And then the other one is that if we read it, again, read it in this way, that x is greater than -4, it makes it much plainer. So it doesn't include -4, and it goes this direction. But it can't go any higher than +3 because our other constraint or condition is that x is less than 3. So this is the one where we get a line segment. It's when you have them connected with the word and, you will get a line segment. So in the next screen, let's take a look at what happens if the conditions are an or statement. The conditions for x now are that x divided by 4 is less than 5, or it could be true that double x, 2x, is greater than 50. If either one of these things are true, then the inequality is true. There's going to be a few values, well, an infinite number of values that don't work. It's only going to be a small section of the number line. So see, we don't have to worry about dividing or multiplying by a negative number to undo these. So I can just work this way and multiply this by 4, multiply this side by 4. And our first statement would say that x is less than 20. So that's one of the conditions. And then divide by 2, and we get x is greater than 25. So really anything's going to work as long as it's not between 20 and 25. So the 2 points we're going to put on the number line are the 20 and the 25. And we're going to circle both of them because there's not an equal to. Anything less than 20, we go this direction. Anything greater than 25, we go this direction, and that's our solution. So the things that don't work would be anything in this section of the number line. So 20 doesn't work and 25 doesn't work, but anything less than 20, greater than 25. And there's one more thing that I wanted to show you. There's another way that you can write an and statement, a compound inequality with an and statement. It's actually more concise and fairly easy to solve, so we'll look at that in the next. This is actually, what you're seeing on the screen is a more concise way to write the statement that x minus 14 is greater than 6 and x minus 14 is less than or equal to 32. And it's a very easy, kind of a handy-dandy way to work at solving this. You want to get the variable by itself, this time in the middle, in between the two inequality symbols. And by the way, these inequality symbols they absolutely have to be the same symbol. So if that's a less than symbol, this has to be a less than symbol. They can be a less than or equal to, but you couldn't have a less than symbol here and a greater than symbol here. It's just not the protocol for writing these things. So we want to get the variable by itself. We have to undo subtracting 14, which means we add 14. And we have to add 14 to the left side of the inequality, which would be here, to the 6, and to the right side of the inequality. So we have 3 additions to do. This would be a 0 pair, so that's an easy one. The inequalities are going to stay the same. The symbols will stay the same. If we were multiplying or dividing by a negative number, then both inequalities would switch. 32 and 14 make 46, and 6 and 14 make 20. So the number that we want is greater than 20, and it's less than or equal to 46. Again, you can interpret this very easily if you read it in this way. Start in the middle and say x is greater than 20, and x is less than or equal to 46. Now you can read it this way. 20 is less than x, and x is less than or equal to 46. It makes it a little harder to understand the meaning of it. So I'm going to put in 20 and 46. 46 gets a dot because it has the less than or equal to symbol, and 20 gets a circle. So x can be greater than 20, goes this direction, less than 46 or equal to 46 goes this direction. And this is an and statement, which results in the line segment. And that pretty well covers all the material in 7.4.